So example number 6 is saying that predict the volumetric diffusivity or your volumetric diffusion coefficient for a system of benzene in air. Okay, so your system has benzene, one component, and the other component is air. So that is your two component. And the temperature system is at 100 degrees Celsius and 2 atm. So you need to calculate it by using first the Chapman-Enskog equation, and second by extrapolating from the published value for 0 degrees Celsius and 1 atm. Okay, so this is going to be our STP. So first of all, we'll be using this equation. So in order for us to use this equation, we need to know our value of T. So it's 100 degrees Celsius. So I can just write here, it's going to be 373 Kelvin. Pressure is 2 atm. So pressure, I can write here is 2 atm. First of all, I need to find the value of MA and MB. So molecular weight of benzene is 78.1. Molecular weight of air we can take as 29. So you already know the value of MA and MB. Now we want to find the value of sigma squared AB and omega D. So these are the two values that you have to be careful. So first of all, let's say we want to find the value of sigma squared AB. And we know that the formula is going to be really simple. In order for you to find sigma AB, you just need to find the value of sigma A and sigma B. So the formula for sigma AB is sigma AB is equal to sigma A plus sigma B over 2, right? So this is sigma A over sigma B, and the values are already given to you, 5.349 and 3.711. So if you substitute into this equation, you will get the value of sigma AB is going to be 4.53. Okay, so you have calculated the value of sigma AB. Now if you want to find the value of sigma AB squared, you can just square this value. Okay, the second one is that you want to find the value of omega D. To find the value of omega D, you need to know the value of KT over epsilon AB. So you can just change 1, 2 into AB. 1, 2 or AB or XY is just a representation of you have two component A and B, or component 1 and component 2. Okay. In order for you to find the value of omega D, you need to find the value of epsilon AB, KT over epsilon AB. In order for you to find the value of KT over epsilon AB, first of all, you need to find the value of epsilon AB. So the equation for epsilon AB, based on the description just now, was square root of epsilon A times epsilon B. And in our table, we are given the value of epsilon over K, right? We are not given the value of epsilon, but we are given the value of epsilon over K. So if I just change here epsilon AB over K, so I can make an equation of square root epsilon A over K times epsilon B over K. Okay, so I have just changed the value here, and by substituting the value, you can find the value of epsilon A over K, epsilon B over K in our table. So you'll get the value of epsilon AB over K is equal to 180. Okay, so this is the value of epsilon AB over K. Now, in order for us to find the value of omega D, we need to find the value of KT over epsilon AB. We have found the value of epsilon AB over K. So we need to inverse the value and times the value of T. So we have the value here. If we want to find the value of KT over epsilon AB is going to be equal to 1 over epsilon AB over K times the value of T. And our T must always be in Kelvin. Okay, please make sure that you always write your temperature in Kelvin. So if I were to write here, it's going to be equal to 1 over 180, because I know that the value of epsilon AB over K is 180. So 1 divided by that value is 180 times the value of our temperature is 100 degrees Celsius. 100 degrees Celsius. But this is in degrees Celsius. So to change it in Kelvin, we plus with 273 Kelvin. So we'll get 373. So once you do this, you'll get a value of your KT over epsilon is AB is going to be equal to 2.79. Around there. 2.73 or 4 or 2. Okay. Once you have gotten this value, if you look at our table here, so 2.079 will be around this value, right? 2.066 and 2.184. So our value is around this value. So, sorry, no. So 2.079 is going to be value around here, right? 2.1 and 2.0. So based on that, you can calculate the value of omega D. And based on this one, you should get the value of omega D by using the appendix and by using extrapolation. You can get the value of omega D for this system is equal to 1.062. So now you have gotten the value of temperature, pressure, epsilon AB, omega D, you know the value of MA, MB. So you can just substitute all the values into the equation and you should get the value of your DAB. Okay, DAB is equal to around 0.0668, and the unit, as we mentioned, gonna be cm squared over second. So this is your final answer to calculate the value of your diffusion coefficient for benzene in air at 100 degrees Celsius and 2 atm. So that is the first part of the question. Find the value using the equation. Now we want to find the value based on the extrapolation from the table appendix. So from the appendix, which is this appendix, right? If you look at here, this appendix, the value of benzene and air, you'll get the value of 0.299. So from appendix, the value of DAB, I can just write here as TP, is actually equal to 0.299 feet squared per hour. Okay, so we want to use this value at standard temperature and pressure, and we want to find the DAB value at 100 degrees Celsius and 2 atm. And we know the equation is going to be DAB STP times the value of P STP over P. You can say here P 100, okay, based on the temperature here, times the value of your temperature of 100, temperature at 100 over temperature of STP to the power of 1.75. Okay, so this is the formula that we will use. So now if you look at here, we always have all the equations. So remember, if you are using feet squared per hour, your answer will be feet squared per hour. But I already got my answer just now was in centimeters squared per second. So what I do is that first I change this value into centimeter per second. So what I can do is that I can use conversion and then I can get my DAB at STP. I convert the unit, I'll get a value of 0.07272 cm squared per second. So I just change the unit from 0.299 feet squared per hour. I change it into cm squared per second. Now, if I substitute this value into this equation, so I'll get my DAB value at 100 degrees Celsius and 2 atm is equal to, so again, since I have cm squared per second, everything else, the unit for everything else will cancel out with each other. So I'll get a final value of the DAB is 0.0666 cm squared per second. So you can see here, based on this equation, I got a value of 0.666. But by using the equation just now, if I just write here, my DAB using Chapman-Enskog equation, I got a value of 0.0668 cm squared per second. So you can say that these two values are very similar to each other. So meaning that we can use either of these two equations to actually find the value of our diffusion coefficient for any gaseous system.